everybody, and welcome to this video on functions. In this video, we will be looking at the inverse of an exponential graph. Now, the inverse of an exponential graph has its own name. It's called a log graph. So the first thing we're going to go over is how to convert from exponential form to log form. That's quite important because, as you can remember, to get an inverse, we swap x and y and solve for y. And if we do that to an exponential graph, it's requiring us to make the exponent the subject. So here is how to convert it. So we have y is equal to a over x, and this is exponential form. So the exponent becomes the subject, and then it's equal to log, the log, and then the base of the log is what's at the bottom, and the base of the log is the same as the base of the exponent, and what was on the other side of the equation just goes on the other side. So please practice being able to convert something from exponential form to log form, because that is quite important to get the equation of the log graph, your inverse. Then what we have over here is our exponential graph that's plotted over here in pink, called f. If you remember the properties of the exponential graph, the domain is x is an element of real numbers, the range is y is an element from the asymptote to infinity, because this is a positive one. So from whatever the asymptote is to infinity. And we have that an asymptote is y is equal to q. Okay, so we have that the asymptote is y is equal to q. These are properties for the exponential graph. Now, the log graph is the reflection about the line y is equal to x. So here we have y is equal to x, and this is the reflection. So you see that the green graph is the reflection if the blue line was the mirror. Now, the green line, or the inverse, is known as the log graph. The domain of the log graph, the x values it takes, is from the asymptote to infinity. So can you see what used to be the range is now the domain? So the asymptote to infinity, the range is now, you can see it takes all y values. So y is an element of real numbers. And again, you should notice that that and that has the domain of the old graph is now the range of the inverse. And then finally, the log graph has an asymptote. You see there's no graph below our domain. So the asymptote is y, instead of being y is equal to q, now it is x is equal to q. So just in typical properties of an inverse is everything that used to belong to x now belongs to y of the inverse, and whatever used to belong to y of the original graph belongs to x of the inverse. So let us have an example of this y is equal to 2 over x. So let's first talk about its properties. So this graph has a positive a, so it's got that positive shape. Its asymptote is y is equal to q. Its domain is x is an element of r, and the range, and the q value is 0 in this case. So it's y is equal to 0, so the x-axis. The range is y is an element from 0 to infinity because of the positive shape. Please, if you do not know how to get this, please watch our previous video on the exponential graph and the properties. It's very important for you to know that. So let us plot this graph. So I like to do a little table for the exponential graph if there's no x and y intercepts, and I'll just do for -1, 0, and 1. So 2 to the power of -1 is a half, so this is for x and that's for y. 2 to the power of 0 is 1, and 2 to the power of 1 is 2. So for -1, 0, and 1, I will have, plot it. So for -1 it's a half, for 0 is 2, and 1 is that. So we have this shape here. Look at that beautiful exponential graph. So that's our graph F. It has no x-intercept because, as you can see, the x-axis is the asymptote. Let us go ahead and find our inverse. So for the inverse, you remember the rule is that we swap x and y and solve for y. Okay, so what we have is x is equal to 2 to the power of y. Now we would like to make y the subject, so we're going to use the log. So y is equal to log. The base of the log is the base of the exponent 2, and what goes on the other side is the x. So if inverse, oh sorry, this is G inverse is equal to log 2x. Okay. Okay, so let's just write this G nicely. Okay, so there is our graph and the inverse. So let us talk about what would be how would we plot the inverse and the properties of the inverse. So the properties of the inverse, okay, it will be swapped around. So now it will not have an asymptote at y is equal to 0. It will have an asymptote at x is equal to 0. The domain will be what the range used to be. So the domain will be x is an element from 0 to infinity, and the range will be y is an element of real numbers. To plot our inverse, I'm going to swap these coordinates because that's what we're doing for the inverse. So the x and the y, so this here is a half and minus 1. This here is 1 and 0, and this here is 2 and 1. So when x is, when y is 1, x is 2. So there's 1 point. When x is 1, y is 0. And when x is, when x is 2, or we did that one, when x is minus 1, then y is minus a half. So that's 1, so minus a half is somewhere. Oh, sorry, a half, not minus a half. Okay, and then we're going to join our dots. Okay, that was actually a terrible job at joining dots. Okay. Okay, and there is our G inverse. And if you've drawn it correctly, it should be symmetrical about the line y is equal to x. So our original graph had no x-intercept. Our inverse will have no y-intercept. So everything that used to belong to x now belongs to y, and whatever used to belong to y now belongs to x. Please make sure that you understand the properties of the original exponential graph well before starting the inverses. And if you have understood it, please watch the rest of our series on functions.